Hello, my name is Alan Kelly and I would like to show you the correct way of calculating return on investment. In doing so, I hope to both demystify return on investment, ROI, and show you how simple it is, and simultaneously show you why iterative delivery, also called agile delivery, techniques massively increase your ROI. Really, I should have made this video 10 years ago, because this fact answers the question that everybody was asking back then: what is the business case for Agile? And simply, the business case for Agile is it increases your return on investment. Even before you do any technical practices or consider quality, even before you consider risk, at its most basic, Agile working will increase your return on investment. So without further ado, let's go on. I'm going to use Excel here. You could probably use any spreadsheet you like. You could calculate it by hand if you like, but I'm going to assume most of you got Excel. We're going to start with a blank project there. Okay, so let's get started. We are doing our project. Let's make it pretty obvious there. Up we go. Okay, and we start off by saying cost. And we'll say 1.2 million, I think. And we'll say benefits. And to keep things simple, we'll say 1.8 million. Okay, let's put them both in dollars. So we currency. Okay, there we go. Oops, need an extra zero there. There we go. Okay. At this point, many people would do a rather simple calculation. They would say our return on investment is the benefits minus the cost. Okay? Or they might say the ROI is the benefits divided by the costs, in which case you get 1.5, 50%, half again, you're getting half as much benefit again, so 50%. That's probably the way most people would quickly do ROI. However, both of these are wrong, and they are wrong for one very important reason, is to take the costs and benefits as one-time things, as one-time events, and to assume that all our costs occur at one point in time and all the benefits accrue at another point in time, and probably a point of time that occurs immediately after our benefits. Unless that is the profile of your costs and benefits, you spend all the money in one go and then you get all the benefits in one go, you need to think again. You need to consider the time here, when the costs occur and when the benefits occur. So let's say our project is going to play out over a year. And each month for 12 months, we spend 1/12 of our costs. $100,000 for 12 months means we spend a total of $1.2 million. And let's suppose at the very end, the day after the project completes, we get all the 1.8 million benefits. So that's our simple model. By the way, I should say at this point that I'm going to ignore the effects of inflation here. The longer your project is expected to run, the greater the need for you to include inflation in your modeling. However, in the context of this explanation, inflation doesn't change my core argument. Maybe I'll record another video which can show how you can include inflation in your calculations. But for the moment, we're safe to ignore it to illustrate this point. Now, to calculate our return on investment, we're going to use two formulas which already exist in Excel. One is net present value, NPV, and the other is IRR, internal rate of return. Now, both IRR and NPV mean that we need to consider the cash flows in the company. That is to say, for each month, how much money comes in, how much money goes out. So in this model, our cash flow in the first month is no benefit, so no money in, but $100,000 out. And this happens all the way through the project until we get to that day after the final work day, the day on which we deliver the project, and all our benefit accrues. So there we go. There's our cash flows. 100,000 out each month. Now, to calculate NPV, it's very simple. You call up the NPV function in Excel. But before I do that, we need to stop and consider one more thing. To work with NPV, we need to know the discount rate of money. This is basically the interest rate at the bank. It's the generally available rate at which you can borrow money. Okay, so for simplicity's sake, let's say that is 5% for a year. Now, NPV, we are modeling this per month, so we need that to be divided by 12. Okay, so it's 0.42% per month. So back to our NPV calculation here. NPV, we give it the discount rate, 0.42. We then give it our cash flows for the year. There we are. And the answer is $537,000. Notice that is a little bit lower than our simplistic ROI calculation of 600,000. Again, one reason why you don't want to use the simplistic calculation. When you are spending money month on month, you are incurring some interest payments, either to borrow the money or interest that you are not getting because you have spent the money. Therefore, we need to deduct that from the rate of return. So for this traditional big bang, all the benefits at the end project, 537,000. The other way of calculating return on investment is the IRR function. And for this, we just need the cash flows. So we don't need our discount rate here. And here, just put it in, and we get 6%. 6% is a lot less than the 50% we thought we might be getting before. But 6% is more realistic because we're going a whole year with no benefits accruing. We are having to wait a year until we get our benefits. And during that year, we're spending. So the important thing at this point is this is the correct way to model return on investment. Look at your cash flows, spread your cash flows out over time, and if necessary, incorporate the discount rate of money. Now it's time to think about an iterative delivery. So here I've modeled out our cash flows again. Our spend is exactly the same as before, 100,000 a month going out. We've also assumed that in the first month there's no benefit. It takes 1 month to get going. So at the end of the first month we have a negative cash flow. After that, in each month, we deliver 1/12 of our benefit. And we continue that until the final day after the end of the project when we deliver one. So you can imagine this as delivering all the benefit from the previous month on the first of the month. Consequently, our cash flows here are negative in the first month, but then they go positive. And in the final month, they're very positive. So now, let's do our NPV and IRR calculation again. Net present value equals NPV. Remember our monthly discount rate. Then our cash flows. Hey, 576,790. That is slightly more than we had in the previous model. We have got an extra $39,000 in there. This is going to pounds here. Now, IRR, just the same as before, IRR with our cash flows. 50%. 50% is an awful lot higher than the 6% we had a moment ago. 50% looks an awful like our naive calculation from before. This looks much more positive because all the way through here we are getting a little bit of benefit. What we are showing here is early delivery improves your return on investment. Delivering something early has a financial upside. Now, let me point out here that we haven't said anything about quality, we haven't said anything about risk, we haven't said anything about feedback. The only change we've really made is to assume that we will deliver the benefits incrementally over the course of the year. But actually, we might want to go further than this. We might want to think of cumulative benefits, because here I have assumed that a 12th of all the benefit accrues each month, whereas what you will find in month 1 you deliver no benefit, in month 2 you deliver benefit, in month 3 you deliver more benefit, but the benefit you're delivering is on top of the benefit you delivered in month 2. And when you deliver benefit in month 4, you've still got the benefits from months 3 and month 2. So perhaps we'd be better off looking at cumulative benefits. So here is another model I've put together. This is our cumulative benefits. So in this model, you'll notice the benefits accruing each month are far less. I've given up on spreading them evenly. This is perhaps more realistic. We get no benefit in the first month, a little bit in the second, a little bit more in the third, then we start to get plateau and we get the same benefits each month. These benefits may be a lot more achievable than the 150,000 we had in before. So this is perhaps a more realistic model. But our cumulative benefits here, because we are getting each month we get the benefit of previous months, our cumulative benefits over this period is actually slightly more than we had in the previous model. It's 1.9 or $2 million there overall. And if you look at our cash flows are negative to start off with, but then they go positive, and our NPV valuation is a lot higher. It is 206,000 more than the original NPV, and our IRR is 16% higher. So even with a lower rate of benefit delivery, we're getting superior IRR, NPV, return on investment. At this point, you can see we're making an awful lot of assumptions here about how the benefits stack up, how much is delivered at one time. I could continue, and maybe I'll continue in some future videos to go over some of the aspects of this and to talk about the assumptions we're making. When you're making assumptions, you're making assumptions about your project and how you want to model it. I've shown you that a like-for-like comparison using the same numbers comes out superior in an iterative and incremental fashion. Beyond that, there's a lot of assumptions we could talk about. If you'd like to talk some more, you can contact me at this address, alan@alankelly.net. And if you prefer it, I'm available on LinkedIn. Again, it's all very simple to find me. Drop me a note, however you prefer. Let's talk about this some more. I'm happy to go over creating a model for your project. Please be in touch. Thank you. Goodbye.